In this video, I will talk about two applications of the equation of continuity. The first one, let's say that this is your garden hose, and you have the water is flowing in the garden hose, and you want the water though to reach a little bit further away. So it tends to, right now it may be doing something like this, but you want to reach somewhere further away. What do you do? Well, in that case, what we will end up doing, we will probably cover some of the tip of the garden hose, and we know from experience that when we do that, the speed of the water that is coming out is greater. Now, I want to remind you, for the equation of continuity, what I have is that Q1 equals Q2, and this means V1 times the area is equal to V2 times the area 2. Now, if I make this to be 0.1 and this to be 0.2, where I have my finger covering most of the tip of the garden hose, then the area to this here will be small, this here will be large, and this means I'll have a small speed of the water flowing in the garden hose, but at the tip where I'm covering most of the tip, most of that area is covered, then I will end up having a large speed. This is how I can make the water to go to flow fast, to move fast as it's coming from the garden hose. This is an example of the equation of continuity. Now, one more example. If we say that this is your faucet, and you turn it on and the water starts moving downwards, okay, the water starts flowing. Take a look. The next time that you let the water run, let it run for a couple of seconds, and then you will see what you will see with water is that as it's moving downwards, the shape, what you get is something that looks like this. And of course, you will see that. So this is the water flowing. What you will see is that the diameter, or the radius of the water moving downwards, is getting smaller. So as you go here, you will end up having a smaller radius, a smaller diameter, or another way to talk about it is that you have a smaller cross-sectional area. Now, why is that? It's still true, the equation of continuity, still true. Q1 equals Q2, the speed at 1 times the area at 1 equals the speed of 2 times the area at 2. Now, if I make this to be 1 and here is 2, what is the water doing as right after it leaves from the faucet? It's falling under the influence of the gravitational force. And we know when something falls, and there is the dominant force is the force from the earth, I know that the water will speed up. There will be an acceleration pointing downwards. The water will speed up as it's moving downwards. This means that the velocity at 2, okay, you will end up having a large speed at 2, whereas the speed at 1 was smaller. Now, I start with a large area. So let's say I started with a large area. Then small times a small number times a large number equals a large number times the area 2 needs to be a small number for the two sides to be equal. This is consistent with what you observe experimentally. The area here is going to be smaller, and the more you let the water run from a greater height, of course, the more the water will speed up, and then you will see a smaller and smaller diameter of the fluid flowing downwards. So these are two examples of how you can use how we use the question of continuity in everyday life.